Hey guys, in this video I will discuss the mean value theorem and walk through an example to show how it can be applied. So this theorem applies to functions that are both continuous and differentiable. So let's say we have this function f of x that's both continuous and differentiable in this interval from a to b. This theorem says that there must be some value c that's between a and b, where the derivative of the function is equal to the average rate of change of the function from a to b. So let's take a look at this graphically using slopes and tangents. So if we connect the point at a and b on this function, we get this line. And the slope of this line is the average rate of change between a and b. So this theorem says that for some point between a and b, if we draw a line tangent to the curve, then it must have the same slope as this line. And we can see this somewhere over here. If we draw a line tangent to the curve, at this point, which is between a and b, we see that it's parallel to this line, meaning it has the same slope. Now let's take a look at an example to see how this can be applied. Let f of x be a differentiable function such that f of 2 equals 4 and f of 4 equals 7. Show that there must be a value of c between 2 and 4 where the derivative of the function is 3 over 2. So first of all, we should make sure that we can use this theorem. Since this function is differentiable, the mean value theorem does apply because all the differentiable functions are continuous. So let's first find the average rate of change between these 2 points. We can see that it's 3/2. So since the average rate of change between x equals 2 and 4 is 3/2, there must be a point between x equals 2 and 4 where the instantaneous rate of change is 3/2. This means that the derivative at that point is 3/2.